Anil Kumar. Here is a review for our grade 9 students who have taken up MPM1D. In this video, we'll discuss questions relating to linear relations. We have 12 questions, so we have 12 questions to work with. In this series of review, I'll take up 5 test papers. They will help you to understand the complete course which you have learned here in grade 9. So let's begin with the very first question, which is question number 1. Simplify and evaluate each of the following. So 5 over 3 minus 2 times half minus 1 over 3. So do this by first expanding the right side. So we can write this as 5 over 3 minus. So when you multiply with minus, the sign will change. So we get 2 times half. Now we have minus times minus, which is plus. We get 2 times 1 over 3. Correct? So that gives you 5 over 3. 2 divided by 2 is 1. So we get 1 here plus 2 over 3. Correct? Now 5 over 3 and 2 over 3 can be combined. So 5, let me rewrite this. We have 5 over 3 plus 2 over 3. And from this, we'll take away 1, right? So you could actually, 5 plus 2 is 7. So we do 7 over 3 minus 1, right? Now, to do this, we have to take a common denominator. 1 could be written as 3 over 3. So we could write this as 7 over 3 minus 3 over 3, which gives us 4 over 3 as the answer. Perfect. So we could write this as 4 over 3. Now there could be other ways to do it. We could have taken a common denominator and then continued. However, we'll use common denominator in example 2. Right. So in this example, we'll see how to use common denominator. Now, in part B, we have 2 over 3 plus 3, and then we have a layer of fractions. So let's see how to solve this. As far as the numerator is concerned, we could take a denominator of 3 as common. So we get 2 plus 3 times 3 as 9. Everything over. In the denominator part, the common denominator is 9, right? 3 times 3 is 9. To make this 9, I have to multiply this by 3. So we get 3 plus 2. Do you see that part, right? So we could write this as 2 plus 9 is 11 over 3 over 3 plus 2 is 5 over 9, right? Now that could also be written as 11 over 3 times. Now the denominator 5 over 9, like dividing by 5 over 9, is same as multiplication of 9 over 5. Now that could be simplified. We could cancel this by 3. So we get our answer as 33 over 5. Is that clear to you? So that is how we are going to solve it. So I'd like you to go through this. This is the basic part of our linear relations. So we are doing some arithmetic before getting into linear equations. Now let's take question number 2, which is basically multiplying polynomials, right? Or working with exponents. So these are the basic skills required. Question number 2 is simplify each of the following. We have 2a squared plus 1 minus b squared times 3a minus a. Now 3a should be multiplied with each of the terms inside this bracket. Clear? So let's do that. So we get 3a times 2a squared gives us 6. 3 times 2 is 6. A squared times a is a cube plus 3a minus 3b squared a. And we have here minus a. Now this minus a and 3a, they are similar terms, so they could be simplified. So we could write this as 6a cubed. 3a minus a is 2a, right? Minus 3, it's better to write a first, ab squared. Is that clear to you? So that is how we are going to solve it. B is relating to exponents. So when we have power outside, it gets multiplied. So when you open, Don't forget to write 2 cube, right? This is kind of important. Sometimes you may miss 2 cube, y to the power of 3, x to the power of 3 times 3, 9, okay, not 6. And here we multiply by y square, so we get 4 x y cube. Do you see that? Now, as far as the numbers are concerned, 2 cube is 8, right? So we have 8 over 4. These are the numbers. Y is y3 minus 3 is 0. They get cancelled. As far as x is concerned, we get 9 minus 1, right? So I'm writing 3 minus 3. I should have written 0 and got it off. 8 divided by 4 is 2, and that is y to the power of 0, which is 1, and x to the power of 8, so that is our answer. Is that clear to you? That is how we are going to simplify the expression. So we get 2 times x to the power of 8 as our result. Now the next polynomial here is 3a plus b whole square minus a minus 2b whole square. Now remember, a plus b whole square is what? A plus b whole square is a square plus 2ab plus b square. And if we have negative here, this sign is negative. So that's the formula which we are going to use. So let's square this. 3a square. 3 square is 9. So we could write this as 9a square plus 3 times 2, 6. 6ab plus b square minus. It's good to put a bracket here, right? Now, we'll use a minus b whole square formula, getting this as a square minus 2 times 2 is 4ab, and then square of this term, which is 4b square. Clear? Now let's combine the like terms. 9a square minus a square is 8a square. 6ab minus and minus becomes plus. So we get plus 10ab. Plus b square minus 4b square gives us minus 3b square. Correct? So that becomes our solution. Sometimes you may like to actually open the bracket, introduce 2 more steps here, and then solve. Clear? Now let's take the next example, which is question number 3. Find intercepts and then sketch the graph of the line. So we are given the equation of the line as 2x minus 3y plus 6 equals to 0. So let's first find x-intercept. X-intercept means y equals to 0. If I substitute y is 0, I get 2x plus 6 equals to 0. 2x equals to minus 6. X is equals to minus 6 by 2, which is minus 3. Perfect. And now, let us also find what is y-intercept. For y-intercept, x will be equal to 0, right? So we'll substitute x equals to 0 here. So we get 0 minus 3y equals to minus 6. I'm taking 6 to the right side, correct? It's a good practice to even write this as 2x minus 3y equals to minus 6, right? So we save one step. Now, y will be equals to minus 6 divided by minus 3, which is plus 2. So we get x and y intercepts. X-intercept which we got is minus 3, 0, and the y-intercept which we call was 0, 2. Correct? Now to sketch, I'll do a rough sketch. So we have 2 intercepts. Okay. So in this diagram, we are looking for x-intercept of minus 3, 0. So let's say this is 1, 2, 3. So that becomes minus 3. So that is the point. And the y-intercept is 2. Let's say 1 and 2. Right. So this is the point. So joining these two, we get our line. Clear? Where this goes through point 2, and that is minus 3. So that is the sketch of our line, which is y. Is that clear, right? So that is how we could sketch it. So I hope it is absolutely clear. So whenever you are given equation in standard form, find intercepts, then graph. Solve the following equations and then check your solution, right? So it's important to check your solution. So let's begin with the very first one. To solve basically means find the value of x. Okay. So what we have here is 2x minus 6 divided by 3. And here, we should have a common denominator of 3, right? So what we can do is, we can multiply both these terms also by 3. So we can extend this. We have minus 3 times x, and 4 times 3 is 12, plus 12 equals to 0. Does it make sense to you, right? So that is how we could do it. You could actually take these terms to the right side, cross multiply, and then also solve. That could be there. But we could take common denominator 3 and then do. So here we get 2x minus 3x, which is minus x. And minus 6 plus 12 is plus 6 equals to 0. Okay? So that gives you 6 equals to x. Now 3, when you cross multiply with 0, it becomes 0. So we have got rid of this 3. Do you see that? So we get x as equal to 6 in our answer. Now let us check. Check really means we'll substitute the value here and see whether the left side is equal to right side or not. Substituting 6, we get 2 times 6 minus 6 over 3 minus 6 plus 4, right? So that is what we need to check. 2 times 6 is 12. 12 minus 6 is 6 over 3 minus 6 plus 4. And 6 over 3 is 2. So we get 2 minus 6 plus 4. And that is indeed equal to 0, which is the right side. Is that clear? So it is okay. Correct? So that is our check. Let's do the next question. Here, 2x and x are in the denominator. So let's take the common denominator. So we could write the left side as 2x with common denominator. We have 3 plus 2x. 2 times 4 in the numerator equals to 22. Now we'll cross multiply. And here we have 3 plus 8, which is 11, right? So we have 3 plus 8 equals to 22 times 2x. Clear? 3 plus 8 is 11. And we are going to divide this by 44. Here we have 44x, correct? To get the value of x, we'll do 11 divided by 44, and we get a value of 1 over 4. So we have x as 1 over 4. Now let's check this solution. To check, let me substitute 1 over 4 here. So we have 3 over 2 times 1 over 4 plus 4 over 1 over 4. Clearly? So that gives us 3 over. That gives you half, right? 1 over 2. That 4 goes in the top, we get 16, correct? Now here, half means 3 times 2, 6, right? 6 plus 16, which is equal to 22, which is our right side. Clear? So it works. Perfect. The next question here is question number 5. Isolate the indicated variable. First equation is t equals to 2 pi square root L over g. We need to isolate g. The second one is a square minus b cube equals to 2 pi. We have to isolate b. Okay, so let's do it. So let me rewrite this equation. T equals to 2 pi square root of L over g. Now we can divide by 2 pi, so we get t over 2 pi equals to square root of L over g. Right? Now we could square to take care of this. So we get t over 2 pi whole square equals to L over g. Right? Now to isolate g, we will cross multiply, and then we can write g as equal to, we cross multiply it, so L times, we get 2 pi. When you square this, let me write this as over t whole square. Is that clear, right? So we wrote g equals to L times 2 pi whole square over t. Now let me take it to the right side to do further calculations. So we get g equals to square of 2 pi gives you 4 pi square, right? over t square. And here we have L. Is it okay? So basically, G is equals to 4 pi square times L over t square. So that becomes the formula for G. Is that clear? Okay. Let's do part B now. A square minus B cube equals to 2 pi. Let's write down. A square minus B cube equals to 2 pi. We need to isolate B. Okay. So let's take B to the other side. So we get A square minus 2 pi equals to B cube. Is that clear? So that means we are writing B cube is A square minus 2 pi. So B is cube root of A square minus 2 pi. Clear? So that is how we are going to isolate B. Perfect. So these are very important steps. I'd like you to pause the video, check these steps, and then move forward. Question number 6. Change the equation of line 3x minus 4y minus 6 equals to 0 to slope-intercept form. That means y equals to mx plus b. And then find its slope and y-intercept. So we have to rearrange, right? So we have the equation 3x minus 4y minus 6 equals to 0, right? So we can actually take these terms to the right side. We get minus 4y equals to minus 3x plus 6. Now divide by minus 4. So y equals to minus 3 divided by minus 4 plus 6 divided by minus 4, right? So that gives us 3 over 4x minus, you could simplify this also. Let me write as 6 over 4 for the time being. So I'm going to simplify that. So we get y equals to 3 over 4x minus, dividing both by 2, we get 3 over 2. Correct? Now from here clearly, comparing it with y equals to mx plus b, we can write down that the slope is 3 over 4 and y-intercept is minus 3 over 2. Is that clear? So that is how you could do it. Now there is an alternate way. In this step, we could kind of take 4y to the right side, right? So let me do alternate method also. That is shorter. So what we do is, we actually take minus 4y. So we write this as 3x minus 6 equals to 4y, right? So you avoid too many negatives. So we could write this as 4y equals to 3x minus 6, y equals to 3 over 4x minus 6 over 4, which is the same result. So we get y equals to 3 over 4x minus, dividing by 2, 3 over 2, right? So which is the same thing. So you could do like this. So I hope all these steps are absolutely clear, right? Let's move on and take 7th question now. Write equation of line perpendicular to this line with same x-intercept as on that line, right? So first thing is, we want to find perpendicular to 2x plus 3y equals to 0. Let's work on this. So let's find the slope of this line. So rearrange, we get 3y equals to minus 2x, y equals to minus 2 over 3x. So slope is minus 2 over 3, right? That is the slope. So what is going to be the slope of perpendicular line? Will be negative reciprocal, which is 3 over 2, correct? So that is one thing. So we have done part of it. We know now slope. Now, let us find the x-intercepts. We find x-intercept of y equals to 2x minus 3. So that is tricky, right? Some of you might just take the value minus 3. That is the y-intercept, not x-intercept. So for x-intercept, y is equal to 0. we need to find the value of x. We get 0 equals to 2 times x minus 3. So 3 equals to 2x. So we get 3 over 2 as the value of x. Correct? So basically the x-intercept is 3 over 2, 0. That is the x-intercept. You get the idea. Perfect. We need to write equation of a line perpendicular to this. That means the slope should be 3 over 2, right? And a point is same x-intercept, means this is the same point, right? So we have slope m of 3 over 2, and we have a point which is the x-intercept as 3 over 2, 0. Is that clear to you? So that is what conditions are given to us. So the line will be y equals to, we'll write here, y equals to 3 over 2x plus b. Now to find the value of b, we'll substitute 3 over 2 for x and 0 for y. So we get 0 equals to 3 over 2 times 3 over 2 plus b. And that gives you the value of b as minus 9 over 4. Correct? So once we get this value, minus 9 over 4, we can write y equals to 3 over 2x minus 9 over 4. Clear? So that will be our equation in slope-intercept form. We actually could convert this to standard form. So sometimes that may be the requirement. See how. So we'll multiply everything by 4. So we could write this as 4y equals to 2 times 3, which is 6x, minus 9, right? Bringing them all together, we get 6x minus 4y minus 9 equals to 0. So that could also be sometimes required. Convert that to standard form. Do you get the idea? So what we did was we found this equation. Well, at times we may also use another formula, which is y minus y1 equals to m times x minus x1 to get the equation in standard form. So that is alternate. So anyway, I like you to use this formula with slope and the point given to you, and then check whether you get the same result or not. Perfect. Let's move on and take question number 8. Now we have 4 word problems relating to linear relations. Question number 8 here is, the Sun Spa charges annual dues of $125 plus $12 per hour to use facilities. The Moon Spa charges annual dues of $230 plus $9 per hour to use the facilities. For what number of hours would the two spas charge the same total amount? That's the question, right? So we have two equations here. So we want the same amount. So charges C for Sun Spa, let me write like this, is basically equal to fixed amount of 125 plus the rate of 12, and the time is t, right? So that is what it is. For the other Moon Spa, the charges are fixed amount of $230 plus 9t, right? We're taking the same time, right? It says for what number of hours would the two spa charge the same total amount? So we want to calculate when will this charge be equal to that. That is what we want to calculate, right? So I hope you have understood the equation, right? Now, so we'll equate these two. So we get 125 plus 12t equals to 230 plus 9t. Bringing variables on one side and the constants on the other. 12 minus 9 is 3t, and here taking away, so 30 with 0, and that is 105. So t is equals to 105 divided by 3, which is 3 times 3 and 15, 35 hours, right? So therefore, for 35 hours, both will charge same amount. Okay, so that is how we are going to do it. Let me extend this. Part B is find this amount. So you can plug in t as 35 in any of these equations and you'll find the same amount. Right? Now, it is important to define your variables. So you should define first, let t be the time in hours and cost be C in dollars. So that could be an important thing. You could begin with this, right? Then get your equation and solve as we have done. So I hope that helps, right? Okay. So let's see the next example, which is question number 9. Segment AB is right bisector of the segment joining the points minus 3, 1 and Q, which is 5, 7. Find the equation of line containing segment AB. So this is a very good question. We are given 2 points P and Q. I'm just drawing like this, where point P is given to us as minus 3, 1 and point Q is given to us as 5, 7. When we say AB is right bisector, that means it'll go through the midpoint, right? So it'll go through the midpoint here. So let's figure out what this midpoint M can be, right? These two should be equal and that will be 90 degrees. Clear? So the first step is find midpoint of PQ. So midpoint will be M, whose value is going to be average value. So add them, divide by 2, right? So midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? So average of the coordinate values. So we get minus 3 plus 5 divided by 2 and 1 plus 7 divided by 2. Clear? So which is same as 2 divided by 2 is 1, 8 divided by 2 is 4, 1, 4. So we get this point as 1, 4. Clear? So that is the first step. Second step here is you need to find slope of PQ. So that is to say, use the formula y2 minus y1 over x2 minus x1. So we get 7 minus 1 divided by 5 minus 3, or 7 minus 1 is 6, and that is 8. So we get slope of 3 over 4. Correct? So then, what is the slope of AB? Slope of AB will be negative reciprocal, negative 4 over 3, correct? And it goes through the point M, which is 1, 4. So we can now find the equation of this line. Clear? So to find this equation, I'll use this form, which is y minus y1 equals to m times x minus x1. Clear? So that's a different form. So y minus, coordinates of y is 4, equals to slope minus 4 over 3 times x minus, x value is 1. Clear? We can now cross multiply with 3. So we get 3 times y minus 4 equals to minus 4 times x minus 1. Open the bracket. 3y minus 12 equals to minus 4x plus 4. Bring them all together. So bringing 4x to the left side give us 4x plus 3y. And minus 12 minus 4 equals to 0. And that gives you the equation 4x plus 3y minus 16 equals to 0. Clear? So that is how you could find this equation, right? You could use slope and intercept form also. However, it is good in review. Practice with different forms of equation, since in the test paper, they could specify any form, okay? Now let's take question number 10. Write equation of the line from given descriptions. A. Line parallel to this with y-intercept of 3. So parallel means same slope, right? So when we say x minus y equals to 2, we can say y equals to x minus 2. Clear? So in this case, slope m is 1. So line parallel to this means slope is 1, and y-intercept of 3. So we could write this as y equals to x plus 3. Is that clear to you? So that becomes your equation of line. Perfect. Right. Part B. Vertical line through 2 minus 3. So let's try to understand this also. We are saying a vertical line which is going through the point 2 minus 3. So x value 2, y value minus 3. Something like this, right? That is what we're looking for, where the point is 2 minus 3, right? So along the vertical line, always the x value remains same. So the equation is x equals to 2. So along the vertical line, x value, the x-intercept is the equation, right? X equals to 2. Equation of x-axis. Now this is our x-axis. So on x-axis, which is horizontal, right? Y value is 0. So the equation of x-axis is y equals to 0. Very important. D. Line perpendicular to this passing through origin, right? So passing through origin means the y-intercept is 0. So directly also you can write, you can swap this, right? So we get the answer as 3x minus 2y equals to 0. That is the answer, right? Just swap and change the sign. But let's follow the method learned. So this is alternate way, right? Okay. Multiple choice questions, that is the best way to do. Line perpendicular to this means you'll do like this. Isolate 3y equals to minus 2x plus 5, y equals to minus 2 over 3x plus 5 over 3, right? So perpendicular line means slope will be 3 over 2, right? So you write the equation and b is equals to 0 since it is going through origin. Therefore, line will be y equals to 3 over 2x, cross multiply, 2y equals to 3x, take it to the same side, 0 equals to 3x minus 2y. Do you see that part? So, for perpendicular lines, you could actually swap x and y coefficients, change one of the signs. You get a line perpendicular, right? That's how we should do it. Okay. Question number 11. So this is a thinking question. It says total cost and number of posters printed is given in the table below. Determine an equation which could represent this linear relations. We are saying this relation is linear. So number of posters 400, it will cost C will be $220. When we say it is linear, we write C equals to some slope which is m times n plus b, right? That is what the equation should be. Okay. How do we find slope? Now, we could find slope using any two values. Perfect. So to find slope, let's say y will be equal to, so these are your n values, so these are your independent variables and that is dependent, right? So difference of these two, which is 250 minus 220 divided by 650 minus 400. Clear? So 250 minus this is 30 and here you get 50 and then 150, correct? Or we get 1 over 5 as the slope. So we get C as equals to 1 over 5n plus b. To find the value of b, we could substitute any one of these values. Let's substitute 300 and 900. Okay, so we get 300, that is the cost. So we get 300 equals to 900 over 5 plus b. Correct? So value of b will be equal to 300 minus 900 over 5, which is common denominator 5. 5 times 3 is 15 minus 900, which is so 1500 take away 900 will be 600 divided by 5. Is that clear to you? Right? So that becomes the value of b. You could divide this. So 1 times 10 is 220. Correct? So we get value of b as 120. So now we can write the cost C as 1 over 5n plus 120. Is that clear to you? So that is how we could check. Write down. Now let's check our answer, right? So if I substitute, let's say 650, what do we get as the cost, right? So if I do 1/5 of 650 and plus 120, what do we get? Let's try. So we're just checking, right? 6, 1, 15 means 3, and then 0. So 130 plus 120 is indeed 250, correct? So which is correct. So that is how you'll be doing it, and if required, you can check it. Here is the last question of our test on linear relations, where we have learned some basic concepts and then developed linear equations and solved some word problems. The question here is, two trains are approaching each other along a parallel tracks. One train travels at 120 kilometers per hour and goes twice as fast as the other. If their distance apart is 480 kilometers, in how many hours will they pass each other? So we have this situation where these are the two trains. Let's say one is traveling here at the speed of 120 kilometers per hour. The other one in a parallel track. So we're saying one train travels at 120 kilometers per hour and goes twice as fast the other. So other is going at half the speed, 60 kilometers per hour. The total distance between these two is 480 kilometers. So in all, let's say time is t, right? So in time t, of course, this will travel much faster. So somewhere here they will meet. So both travel, so both trains, so both trains will travel for duration of t hours, correct? Covering total distance of 480 kilometers. Is that clear, right? So both of them combined together will cover 480 kilometers. We also know the relation between distance, speed, and time. So distance is speed into time. So distance will be how much? 120, this will be 120t. The other one will be 60t, right? So that is the distance. So we get 120t plus 60t should be equal to 480. If you add them, you get 120 plus 60 is 180t equals to 480. So t will be 480 divided by 180, right? So it cancels. So you could divide both by 6, for example. So if you're dividing by 6, you get, or you can use calculator. 6 times 8 is 48, 6 times 3 is 48. So those many hours, 8 by 3 hours, correct? Which is 2 hours. And so you get 2 hours. 3 times 2 is 6. We're left with 2 over 3. So basically 2 hours and 2/3 of 60 minutes. So we converted that to minutes. So which is 3 goes 20 times. So 40. So we get 2 hours and 40 minutes. Is that clear, right? So you could answer like this, converting hours to minutes. So basically what we did was 8 over 3 could be written as 2 over 3 hours, right? And then to get minutes, we multiply 2 over 3 by 60. So that goes 20 times. 20 times 2 is 40. So we get 2 hours and 40 minutes. Is that clear? So with that, we end this review on linear relations, where we have actually touched upon some very basic concepts, working with expressions and polynomials. And in the next part, we'll talk about area, surface area, volume, and take up questions relating to measurements. So I hope that will help you to review the complete course of grade 9 mathematics. Thanks for watching and all the best.